Hurricanes, hailstorms, tornadoes, and wildfires. These are just some of the weather hazards that displace families and disrupt lives. Many of us are familiar with the scenes of devastation these hazards cause, and the recovery process for affected communities can take months, even years. In the most extreme circumstances, some may never be whole again. This may prompt many of you to ask what's being done to reduce the risks associated with these hazards. To answer this question, the Insurance Institute for Business and Home Safety presents the Disaster Discussions podcast. Join me, your host, Rachel Penton-Goche, as I sit down with professionals in the insurance, science, construction, and resiliency industries who help us explore the intersection of these hazards with the built environment. We'll bring you in-depth conversations with experts from across the country and highlight how science is engineering real-world solutions from home and business owners to create safer, more resilient communities. Join us for these discussions every month, and to make sure you don't miss an episode, go subscribe to the Disaster Discussions podcast on your favorite podcast app. We also invite you to engage with us on social media to ask your questions, share your thoughts, and to learn more about the IBHS mission. Welcome to the Disaster Discussions podcast, where we explore the intersection of weather and the built environment. I'm your host, Rachel Penton-Goche, and in this month's episode, our July episode, we are recapping the annual IBHS Hail Field Deployment. So super excited to talk about this, and joining me today here in the studio, we have Brenna Meisenzahl and Jake Sorber, research project scientists, as well as two of our meteorologist team leads. And joining us remotely, we have Dr. Giammanco, lead research meteorologist, also managing director of standards and data analytics. So welcome to the show, guys.
Yeah, great to be here.
And so I actually got to join you on this trip, myself along with several other IBHS employees, a couple of special guests. We had some wind engineers, we had some other folks with meteorology backgrounds, and we went out in the field for close to 3 weeks. And you guys do this every year. And of course, the goal is to research hail, one of our perils here at IBHS. So just I want to hear a little bit about your backgrounds and kind of how you got involved in meteorology.
Yeah, I mean, ever since I was a little kid, I was always in love with snow. Like, I'd watch the Weather Channel, the 7-day forecasts, and I'd look for those little snowflakes on the forecast. And I wanted Jim Cantor's job, right? Because watching him stand out there in a blizzard in Boston, like, I was a little jealous of that. So yeah, that was kind of the start. And funny enough, I was actually terrified of severe weather growing up.
Really?
And so as I got older, that kind of started to turn more into a passion as I started to learn more about the weather and went to college. And so now here I am chasing severe weather, which is an interesting turn of events,
Yeah, Brenna?
I have always loved weather when I was a kid, although that I never saw that as my path, as my career path now. I actually was starting my associate's degree going for pharmacy and taking pre-pharmacy classes, and found out that that's not what I wanted to do. And I was a huge movie buff when I was younger in college, and I actually got the idea of meteorology from watching the movie The Day After Tomorrow.
Oh, cool. Okay. Yeah. Were you a Twister fan also?
No.
No? Okay. Twister, that was my weather movie. So totally get that. Mm-hmm. And so then you ended up changing career paths?
Yeah. Yep. One of the characters was a paleoclimatologist for NOAA, and I was like, oh, that seems really interesting. And I ended up looking into that career, and yeah, here I am.
Cool. Ian, you have some fun stories, right?
Yeah. So for me, it started when I was probably about 7 years old. My dad showed me this Nova tornado. So PBS Nova documentary is the first one on tornadoes, I think. It had Howie Bluestein in it. Lou Wicker was a graduate student. They were deploying the Toto Tornado Observatory, which was a mobile instrument that you put in the path of tornadoes, which oddly enough is very similar to what we do today, both for severe thunderstorms and hail. And I really just thought that was very interesting. And so, but what solidified it was in 1992, I was going to the 8th grade. Hurricane Andrew made its last landfall in South Louisiana. I grew up in Baton Rouge. I was that kid who was sticking like National Hurricane Center forecast up on a bulletin board in my dad's home office, just That's what I wanted to be. Maybe I was a little kid, like I was fascinated by Bob Sheets and the director of the Hurricane Center. But when Hurricane Andrew made landfall in South Louisiana, that sealed the deal that I wanted to be part of the weather enterprise. But it wasn't until I got to graduate school that I realized combining sort of this passion for multidisciplinary work, whether it's engineering plus atmospheric science and all this field research, was truly where I think I was meant to be from a career path perspective.
So you guys are all involved in the hail research, I know, especially you two. So kind of how did you end up at IBHS, and how did you end up researching hail specifically?
So for me, it all started at Penn State, where I got my undergrad degree and my graduate degree in atmospheric science. I had the opportunity to go on the hail field deployment with one of our partners from Penn State, Matthew Cumgen. And that's where I first met Ian and the team at IBHS. And then the next year, I came on as an intern at IBHS for the sole purpose of helping out with the field deployment. And so I always kind of had my eyes on IBHS as a potential career path, just because of the core values that we have here, the real world impact that we focus on, and also the cool work that we do with hail and wind.
Yeah. How about you, Brenna?
So I was at UNC Charlotte finishing off my undergraduate degree, and one of the girls in my class was actually a previous intern at IBHS, and she had voiced that there was this really cool research lab down in South Carolina that needed summer interns, and I needed an internship. So I ended up coming on in 2018 as an intern, and they luckily had some full-time positions available right when I was graduating. So it just worked out that I came on full-time and kind of joined in the hail and a little bit of the wind space too.
And Ian, you've been on the field deployments now for how many consecutive years? I know you've been here since pretty much the very beginning.
Yeah, so we started it in 2012. Little bit of my path. So my wife Tanya, who was an IBHSer, was on our first group of scientist hires, and I joined IBHS as a contract scientist, working actually on our very first ember generator design way back in 2010, 2011. Oddly enough, with Ann Cope, our chief engineer's husband, Brian. Brian's a design engineer. And so he was on board as well, and that was our first task. But early on in 2012 was our first year in the field, with really the idea to try to see, could we go out and measure a bunch of hailstones? Could we do that very effectively in the field and collect a large amount of data? And then could we actually do strength testing? Because we crush hailstones in the field to get some of the data that we knew we would need over the coming years when it looked at how we were going to change the testing of materials for hail. So that was really the impetus of the field program. Tanya, my wife, she had the thought, like, how do we go collect all this measurement we need? We both had experience in the field from graduate school, and it was really the need to spin up a field program to fill in a huge measurement gap when it comes to understanding the material properties of hailstones. And that's where the program began. Now, back in 2012, and we had a year off for the COVID pandemic. But since then, it's been a pretty much continuously running project. Now with different experimental goals that changes, year to year. And sometimes chunks of years, we have different experimental objectives. But yeah, it's now over a decade of field measurements related to hail and hailstorms.
Yeah, and it really is cool. We mentioned the weather movies. I mean, it's not quite as dramatic as the movies, but it is a bit like what you see on TV. I mean, we're going out ahead of these storms, putting the instruments out. And again, we're doing it from a much safer standpoint. But it was interesting to see. I'd been in the field just only one time previously, and I have never seen actual research being done. So it was really cool to see you guys, how this kind of all comes together. So I do want to talk about the planning that goes into this. This is just under 3 weeks or so, but you guys put months of work into this. I know you're really involved in some of the travel arrangements and things. So kind of just tell me where you start when you guys are kind of in the months leading up to the deployment. Where do you even begin when you get ready for something like this?
It almost sometimes starts the year prior, right after deployment. We start, figuring out what needs to be done to get ready for the next year, whether that's refabbing some distrometers or creating new ones. And then even just 6 months prior, that's where we get our van reservations, and distrometer calibrations do take a while too. So those usually start in the beginning of the year as well.
And then what about like the planning as far as the teams and kind of getting everyone out there?
Yeah, team planning starts a few months prior. We have an idea of dates of when we're going to be out there, and then we'll start honing in on who's going to be going and what weeks, because we do team swaps halfway through.
Okay, so fast forward to May, just the week of the trip. I know you guys, we get 3 Ford Transit vans. They come here to the center, and then you guys pretty much have to gut them, remove, all sorts of different things from the van and get them actually ready for the field. So talk about that.
Yeah, traditionally, like you said, we gut the vans, and we have to outfit them with radio equipment, put our instruments in there, right? Electricity, so that we need an inverter to be able to plug stuff in. This year, one of the main goals of the deployment was the deployment of panels, right? Asphalt shingle panels. And so there was a few months where we were planning out and designing these racks that would fit into a transit van to hold 16 panels per van, right? So that was a big part of this year as well.
Yeah, so we have the panel racks. We have quite a few distrometers. I don't know what the actual count is. I know it's more than a dozen, right?
24.
Okay, I was on team 1, and the whole van was full of distrometers. We have multiple people. We have the luggage. We've got we've got the cooler for the hailstones as well, the freezer. Of course, all the essentials for being on a road trip, snacks, and all sorts of things. So it's definitely a big endeavor just to get everyone out there. And Ian, once we actually get all our crew members and we get into the field, just kind of talk about the deployment and where we began on day 1 with each year's deployment.
Yeah, I'm going to rewind a little bit back to, Jake mentioned some of the work we do getting the vehicle set up. The team back at the lab developed these racks that install into the seat rails, the existing seat rails of the vans, which is a really amazing engineering. 1, it's highly safe, which is tremendous. 2, it keeps things very organized. So when you're living in a van for 2 weeks, you want as much organization as you can get. So I wanted just a big shout out to the team back at the lab that worked through that. We even 3D scanned the inside of transit vans to get exact dimensions and 1, to make sure what we're doing is safe, but 2, to have a system that's very efficient. That's one of the things about field research. When you're doing all this stuff in that environment, this is not like you're sitting in a laboratory space with everything is right there at your hands. It's all set up for you to sit there and work and do what you need to do. It makes life go smoother, less things break. I always joke some of the best work in the field is actually done in hotel parking lots when you're fixing equipment for the next day. But yeah, so then fast forward to the actual operation day. And so for the last couple of years, we've done a fixed time window. Back early on in the program, we would actually target an active period, ship equipment, fly out, work for probably 5 to 7 days or so, then come home. After the COVID-19 pandemic, some of the logistics and the cost of shipping all that equipment just became too inefficient. The cost to benefit in terms of operation days just wasn't there. So we switched to a fixed window. So now we basically put it on the calendar, try to get about a year in advance. Take a little bit of climatology into account. Like this year, we knew we were headed into a La Nina phase out of El Nino. So we're trying to balance a little bit of the climate information on that. And then you just go. And then you got your set block of days where you're letting the weather tell you where you got to go. And then you just go after it. And that could mean the period's dead. As we'll talk about, this year was absolutely not. We've had a very active, severe season so far this spring. And that's where you start. So the teams departed from the lab. A couple of us flew, met the group in Nashville on the way out. And we sort of hone in on where we think the first region of operations is going to be. For this particular trip, it was going to be in Nebraska, Iowa. So we took the route through St. Louis, through Kansas City, and off we went. And so you do the drive, you get out there, and then, when that first day comes up, you start making your morning forecast like you're going to do for the next 14 days of what is that day's target, what are the storm modes, what are the storm motions, what are the boundaries that are going to initiate storms, and where does the team need to position itself relative to all of these features. And day 1 starts the first of many.
Yeah, late May, early June, as we know, like you mentioned, climatology, that is typically one of the busier periods, and things really worked out well this year. One of the busiest severe weather periods since around 2011. So just kind of talk about the pattern that you guys had. You guys were able to deploy a record number of times this year.
Yeah, 10 IOP days, which blew the previous record of, I believe it was 8 IOP days out of the water. We've talked about this before internally, how these transition years from El Nino to La Nina tend to be very active, and that's visible in the hail day analysis that you can do from previous storm reports from past years, so on and so forth. And so, we had, for a period of time, the traditional southwest flow regime in the upper atmosphere, which storm chasers usually look for a good dry line setup, and like severe activity in Texas and Oklahoma, so on and so forth. And then we also had some days with more of a northwest flow regime, which also have been known to produce storms that produce big hail. So,
yeah, we hit quite a number of states this year. Just kind of talk about some of the places we were able to deploy in this year.
Oh gosh. So yeah, Ian mentioned that we started off in the Nebraska, Iowa area, kind of seemed to make a huge loop throughout the center of the country over the course of the 2.5 weeks we were out there. Like I said, started in Nebraska, Iowa, made our way down into the eastern part of Texas, southern Oklahoma, kind of made our way across the state over to the Panhandle area in New Mexico, up into Colorado a bit, back up into Nebraska, and I believe we went back down.
Yeah, I know one of the days that I was on, just in one day, I think we went from Texas, up to Colorado, Kansas, New Mexico.
Yep.
Like we hit 4 or 5 states just in one day.
Yeah.
So that's where the term nomadic comes in. We say these are nomadic deployments, and that's literally because we have no idea where we're going until we're on the way there, pretty much, or right before.
Right. Yeah.
Yeah.
Covered
So
a lot of ground this year.
Yeah, we take it day by day, and there is no home base. So there's no, we're coming back to some designated city or anything like that. So again, it's you're living in the van, and then hotels are there for just sleeping. So a lot of times, and it always works out, some of the nicer places we've been, you're there for like 7-8 hours or so just to sleep. And that's what you're doing. Before, it's, hey, the target's 4 or 5 hours away. You got to get moving, get going. We try to make some distance at night, but as we've learned over the years, it's one better for sort of team morale, as well as the safety aspect, to try to stay as close to you can where you finish operations for the day, and then make the positioning move the next day. Just because that environment, once you begin a deployment, we talk a lot about the hurry up and wait aspect, but you're going from sort of that very benign, low key environment to something that's actually quite stressful. And very intense, that requires extreme amounts of focus by everybody on the team for a set of about 3-4 hours of just very intense, focused work. And that can drain on you mentally, not just physically. The mental exhaustion too is tough. So you want to make sure you get a good night's sleep. And so we've learned that over the years to stay closer to where we are at the end of the operation days. But yeah, started in Nebraska, down to Oklahoma, Texas, hit New Mexico, back up to Colorado, to Nebraska, tried to target Nebraska, and then ended up in Kansas on the last day, IOP 10. And then I think we even dropped south thinking the next day, but that was a cap bust to finish it off on the very last possible op day for this year.
Yeah, I think we finished in Childress, Texas. I think that was our official last city before we hit the road, if I remember correctly. Yeah. So it is really, it's a surprising range of emotions through the day. Like you wake up and you're tired, but then you get moving and you start doing things. And as the afternoon goes on, you're waiting on the storms, you start to get a little bit more excited, especially when you start seeing things on radar. And then there are periods where you're, kind of bored. There's not much to do. But then, like Ian said, you kind of flip pretty quickly into deployment mode. So just kind of talk about that. I mean, we do a few things throughout the afternoon, but really most of this activity is happening late afternoon, early evening, once we actually decide that we're going to deploy on a storm. And then things can get, a little organized chaos, but a little chaotic.
Yeah, I'd say like for the first 4 hours of the day, it's a lot of like, all right, let's go over here, and we're generally within 2.5, 3 hour drive of where we think convection is going to initiate. And we're watching satellite and seeing where the cumulus clouds are popping up along the boundaries and so on and so forth, and maybe making some positioning moves in there. So it's really like this macro view of the expected area of initiation. And then I think Ian alluded to this, as the day goes on, our focus narrows in to like, okay, here's that boundary that we're going to target. It's like, oh, there's the first towering cumulus cloud. There's the first echo. Oh, this storm probably has hail in it. And so all this narrowing of our focus into our target storm. And throughout that whole time, like, it gets more and more intense. Like, we're like, okay, it's happening. It's time to go.
Yeah, sometimes we had to patiently sit and wait. You know, some of the storms were severe warned. You guys were just still kind of honing in, waiting to pull the trigger, right?
Yeah. Patience is the name of the game. And being too jumpy has been the demise of many storm chaser from getting on the quote unquote storm of the day. But for us initially, as Jake mentioned, it's a lot of what I call positioning moves. You're trying to make sure you have enough space between the axis of storm initiation and where we need. So for this year's mission, we had a couple of different experiments that required different sets of lead time going on at the same time. Rachel, you were with me in T1, and our job was to set up a coarse array of disrometers. We had 8 or 9 probes with us. And so that takes us about 30, 40 minutes to do that. So we need 30, 40 minutes of lead time. Whereas Jake and Brenna were handling the 2 panel teams that needed, you guys maybe 15 minutes or so. You have 2 sites you want to get to. So your lead times you're cut down a lot shorter so you can be more sort of nimble. So we'd pick our target storm, but the key is to be patient. You buy yourself enough time, knowing you've made a good forecast, to try to make sure you can pick a storm that's going to give you measurement opportunities, to be able to do the work you set out to. It's one of the reasons why I enjoy field work so much, because it's not just running the experiment. You got to make a good forecast. You got to be patient. You got to pick the right storm, and then the roads have to cooperate as well to get all your assets into the right spot to make the measurements you need to. So it's one thing, you have the severe weather season, while it goes on for a while, our ability to operate is a short window of time. So you have to make the most of it. And we've gone out year after year to make these measurements over and over again with different experimental objectives, knowing that these challenges will throw you curveballs, sliders, knuckleballs all day long, and being able to adjust. And then sometimes you can't. And you sit there and you put your hands in your head and you just let the storm go, knowing that you coulda, woulda, shoulda, maybe a couple of 3 decisions ago might have changed that outcome, but there's nothing you can do about it. It's out of your control.
Yeah, really, you guys have a long series of decisions each day to make. And then sometimes we had multiple storms on radar. Then you guys were trying to pick out which storm is going to be the best for which teams. And then once we actually chose a storm, then it's kind of like mastering the timing of everything. So there's a lot of things that have to line up correctly to be able to deploy. And then once we do, there's a lot of things that have to line up, like Ian mentioned, once you get out there. So I want to talk about from a meteorological standpoint, we're targeting supercell thunderstorms. Those are the storms that rotate, that produce tornadoes in addition to hail. And we're not targeting storms that make tornadoes. And that's, I think, the big difference between us and most people who are out in the field. A lot of storm chasers, we pass those on the roads, but as part of a scientific experiment specifically targeting hail, we actually don't want to see tornadoes. So talk about how you guys, from the meteorological standpoint, how you choose which storms that we're going to deploy on that are going to have the best chance of producing hail.
Yeah.
Go for it. Yeah, I was going to say this is the fun of doing this podcast remotely. So, I'll start us off, and Jake, you and Brenna can chime in. Supercells make a large percentage of our large 2-inch plus hail every single year. That's in the United States. That's our dominant hail producing mode of thunderstorm. They also produce most of the large, violent, long-track tornadoes we see in the U.S. So trying to understand the environments that contribute to each, and there's some science that's starting to shed light on tornadic phases of supercells may not be exactly the right conditions that also produce hail. Sometimes the environments that are more favorable for tornadoes are not the ones that are ideal for hail. But there's a huge difference between I'm going out storm chasing to go see a tornado versus doing a science experiment, even if you're studying tornadoes for that matter. But we're looking at hail. So we operated on, I think, like 3 or 4 active tornadic storms. We didn't see the tornado at all. So that's the huge difference between just storm chasing. Our role is very different. The area of the storm we're looking at is different. Our strategy for deployments is very different from, say, a conventional storm chaser, if you're out there listening to this podcast. So we actually didn't see some of these tornadoes at all, but we're working a storm that is tornadic. And it's something you always have to keep in your mind, keep your escape routes. I mean, that's what we talk to these guys. We go through that when we're about to, make our moves to roll into a deployment, where we go through what is our escape routes, what's our way, just one out of any situation around a storm, and then off we go. So I'll send it back to Jake and Brenna. You guys can sort of pick this up from the tornadic versus non-tornadic environment. Jake, I know you have some thoughts on why the two may be different as well from a science standpoint.
Yeah, I mean, I think just this year we saw multiple different storms where they were big hail producers, and we targeted them and we set out our array of instruments, and then the hail production started to wane, and all of a sudden the storm spawned a tornado, right? And so I know, Ian, you and I have talked about this, and it seems that whenever these supercells transition into a tornadic phase, the hail production seems to wane or drop off. And so, I mean, a couple of thoughts. Hail production is at its highest when the updraft is wide, right? That's why we look at the shear vector to tilt that updraft and make the updraft wider. And when you get a tornado, one of the ways you can spawn a tornado is by stretching of vorticity. And so when you're stretching that updraft, possibly we're narrowing that updraft, and therefore hail production is dropping off. So that's just a theory. It's not based on any current science right now, but it's interesting to see this in the field.
Yeah, it's something we've been thinking about a lot and bounce this idea around. And it's with the cyclic supercells. The long track ones are the tornado, we used to call them the tornado cyclone ones, which is the El Reno 2013. You could even start to think maybe the Greenfield, Iowa one this year, or go back to Greensburg, Kansas. The long track supercells are doing both. And there's something that's different. There's some balanced state that these thunderstorms are in, where they're not going through their cyclic process. The hail production's going along right with a violent tornado production. And why that is, we have no earthly idea. We don't know scientifically. We know the general environments that support tornadic thunderstorms. It's usually around maximizing low-level turning, the low-level shear. And then you have to have some threshold of instability or buoyancy to get that air to go up. And as Jake said, to kind of stretch the updrafts. But there's all this nuance within these thunderstorms that we just really have no idea about. So we're starting to notice some of these trends out in the field. And it's one of the sort of applied areas of this work where you make all these measurements, and then you have a colleague or collaboration with somebody like Matt Cumgen at Penn State who's doing storm scale modeling. So they can take all this information and look to see, are they seeing the same things in a storm scale simulation in a computer, where you can actually turn one knob on the atmosphere. We can't do that out in the field. We can do that in a computer simulation. But do we start to see the same things we observe in the field showing up in the model data? And that's where we're just starting to get from the hail side of this. We've modeled tornadoes. There's been Lee Orff's countless call them eye candy simulations. Part of me thinks we're chasing some ghosts that are in models that, from an observational perspective, that are features that we may not even be able to observe. But for hail, we're just getting to this point where we can actually simulate hail trajectories. We can look at how those trajectories affect what is the hail concentration, the size distribution at the ground. Do those simulations start to look like the observations that we've been making now for almost a better part of a decade? So we have all this data built up to be able to compare with what we're simulating in some of these models. That's what's going to take us to the future.
Yeah, I heard you guys both mentioned numerous times throughout the field, that's a skinny updraft. We're We're going to forget this storm.
Yeah.
So, okay, I want to talk about when we're actually out there. So, like we mentioned, we get up, we're at the hotel. You guys are data dumping, you're fine tuning the instruments for the day, lots of different things that need to be done, checking up on the vans, making sure they're in good shape. We usually sat down and had lunch somewhere, and then we kind of started repositioning after lunch to get set up in our target area for the day. And then once you guys did, of course, lots of radar watching throughout the afternoon. Once we chose a storm, then we kind of each split up and did our own thing. So T1 was doing its own thing with the distrometers. T2 and 3, you guys had shingle panels and some distrometers. So just talk about once you guys actually, say go, or we're going to deploy on a storm, like what are we actually doing in order to get all this out and get out of the way of the storm? Talk about that.
So we're obviously off from a distance where the storm is. And once we have that go, it's either say T2 or T3 going on their own, just depends on how Ian decides of how we want to deploy it today. So one of our teams could be going off solo and kind of making our decisions somewhat on the fly, but we know we have a plan of where we're going and how we're going to deploy in that storm. Or sometimes both our teams will be together and somewhat doing a leapfrog of where we're deploying panels kind of out ahead of that storm. And like Ian had mentioned, because we have panels, we can be a little bit more aggressive with it and kind of choose those positions and make sure we have our escape routes and constant communication with one another, whether that's through our radios or Slack channels.
Yeah, Rachel, these guys deserve a ton of credit because they're veterans to doing this. So it enabled us to pick a storm. And this is something that, this was the first year for you, but Jake and Brenna has done this now quite a while. We could pick a target storm, and knowing that the two experiments that they were running versus T1, our team, I could let them operate on that same storm as they needed to. They've done this enough. They know how to do this safely. They know how to plan their escape routes, and they know how to move their team where they need to be. And so that was the biggest probably benefit, and I'd say it's almost a luxury as a field coordinator to be able to do that, is to have your team, we pick the target storm, and we can run different experiments now within the same window of time because we have folks who've done this. And this is really important for those team leaders to have all this experience and just understand it. And we'd sit there, I pace between vehicles really bad. And I'm looking at roads, and I'll go point out a road to these guys and say, hey, I think this could work for you guys, but or they're coming to me with an idea. Hey, I think we can get there on this road. We can move this. And if we have to bail, we can go this way or back off from the storm. And then knowing that the distrometer teams that are putting down large numbers, we just have to back off and give ourselves that 30, 40 minutes to do it safely. So it's a kudos to the team that knows the role really, really well, and the process of getting themselves in the right position to do this, one, effectively, efficiently, and safely, has changed sort of the game with the project, allowing us to add some more experimental objectives that we really weren't able to do a few years ago, or going back to the middle part of the project, which is more centered around, let's just make a whole bunch of boatload of measurements of hailstones and crush them and get this big mass data set that we can use in the lab. We've been able to evolve to look at multiple objectives, even within a single year's project.
Yeah, you guys got the panels into quite a few storms, including some big hail as well, and you guys really had some success with that this year.
Yeah, I think it's important to point out, last year we had one panel team, right? And so we had one panel deployment site. It was much harder to hit that bullseye with just one panel. And so this year, having T2 and T3 go out and deploy 2 panel sites each, and so we had a total of an array of 4 panels, kind of cast that wider net. T2 killed it this year with their panel deployments, and they got I think over about 18 panels or something in hail, which
you guys almost
awesome.
Ran out, and you said, hey, we might just go home if we run out.
Yeah, exactly.
We did run out of our panels. We actually had to swap with some of theirs, but we were able to get our panels into some of the same panels into a few different storms, because even though they may have been hit with hail, it might have been small hail that we really didn't notice any damage. So we were able to reuse them. Only one product survived 2 or 3 storms.
Yeah, talk about what's on the panels for people.
Yeah, this year we looked at the products that we've tested here in the lab, impact rated products, and also composite materials like composite shingles, right? And so we strategically chose those to take out into the field to see if we could see any verification of damage modes that we see here in the lab, so on and so forth. And so particularly this year we were testing impact rated asphalt shingle products. And we even had some from last year that we let age for a few months in the sunshine to see if there was any difference in damage between the new product and the aged product as well.
And these are supposed to hold up better to hail than regular shingles, correct?
Correct. The impact rated products are supposed to hold up better to hail. So,
but what have you found? Or do you have any results yet from this year? I know you guys have been just running since the trip, but have you had a chance to make any initial conclusions?
We have. So we have the data, but we haven't done any image processing yet.
Okay.
But that's coming up on the docket.
But you guys are doing this to kind of, like you mentioned, correlate what you're seeing here in the lab. So just kind of talk about that aspect and how you guys are going to link what you learn in the field to what you've learned and are learning here in the lab.
I know. So the lab piece, when we impact our shingles in our hail lab, it was noted that I believe it was 2-inch or 2.5-inch hail. We were seeing the decking on the back of it actually cracking, and we didn't know if that was just our kinetic energy that we had or the speed that we had for our hailstones were a little bit off. So we really wanted to make that connection to, is this actually happening in the field? Is our homeowners actually experiencing this? Because you don't normally go up into your attic and check your deck. And then I'll let you talk about the kinetic energy portion of it.
Yeah, so along with these panels, we deploy distrometers, right? And traditionally from distrometers, we gather the impact kinetic energy data, the concentration of hailstones, the size distribution of hailstones, all this stuff, right? And that all went into informing the sizes and the number of impacts that we do on the panels in the lab. But when you have the damage severity on these panels that the image analysis gives us, and then we have the kinetic energy from the impact distrometer, we can develop this relationship, this kinetic energy to damage severity relationship. And so that'll help us glean even more information about these individual asphalt shingle products, which ones are the best performers, which ones are the poorer performers, right? So that's kind of where we're headed with this analysis on these panels.
Yeah, and I know, Ian, you mentioned we're going to take some of this data back to the lab, and we're actually going to recreate some of these storm scenarios that you guys have encountered in the field, and eventually we're going to be doing even more full-scale testing here at the lab, but with hail.
Yeah, so a lot of this, as Jake mentioned, is to, one, sort of validate some of the modes of damage that we see in the lab with potentially what's going on in real hailstorms, but also as Jake and Brenna mentioned too, is take some of our good performing materials and how durable are they? I mean, that's a big question, right? We know they can perform in the individual controlled laboratory testing space. We understand that very well, but how durable are they? Can they handle multiple hailstorms? This is the keys to starting to knock some of the dollars off of hail. It's sort of our thought. We're replacing probably far too many roofs that simply don't need to be replaced as we sit today. But can our bigger or better performing materials even take more hail than we're giving them credit for, especially the newer products? But then there's the age question. We'll solve some of those things in the lab. But then as we go to sort of the big question is, well, what does this mean for full roof system performance? You know, we did a full-scale hailstorm simulation that was based on arbitrary numbers back in 2013 in the big chamber at IBHS. We have not done a full-scale test since. We have done most of our work in the small laboratory space developing our new test protocol. But now, as we've gotten all this information about hail sizes, what is the distribution and concentration, just like wind, where we can go punch up a wind record from an actual event. Say, like, I'm going to go run the Hurricane Ike eye wall wind record in the big test chamber. I'm going to go run a thunderstorm outflow wind trace in the big test chamber. I'm going to go run Hurricane Florence, 24 hours of Hurricane Cat 1 winds and rain simulation. Well, now we've got enough to do that with hail and also revamp the system that we built way back when, that I was a part of back in that era. So I know the limitations of that system, with a new setup that'll enable us to do this full roof system testing. So we can do hail impact work, then we can look at the water entry potential. We could look at the aging of a full roof system that's experienced a certain type of hailstorm. Then we also need to get that capability over in the small lab too. We've started to work our way that direction, where we can take another panel and just run it right through the same event that we had in the field, and start to look at, hey, is our lab data, is this all working together? Is all what we think it is? And that's the one thing about science. And I've always told folks, IBHS, the work we do sits in this space where you can learn a lot simply by looking. If you go look at this problem, you're going to start to uncover what are the issues? 2, what do we got to learn? What are the gaps? And then 2, what are the solutions in the end, and those practical solutions that we're sort of known for? So that's the look at how some of this data that we've collected in the field is going to turn into work that you'll see come from the IBHS Research Center over the next coming years for sure.
Yeah, I just think of these groups that we have come through the center, and every single time a group comes through, after we show them what the hail does, we talk about the wind, everyone asks, so what is the best thing I can put on my roof? And every time we have to say, well, we don't know yet. We're trying to figure that out. So hopefully this research, this field research, and what we do at the lab, hopefully we'll be able to eventually have an answer for that question.
Yeah.
It's a popular question.
Oh yeah, yeah, and we're doing pretty well with the asphalt shingle side of things. Like we try to give out updated impact ratings I believe it's every 2 years. Correct me if I'm wrong. But then like composite materials, right? So those are the areas that we're still trying to fill in the holes. So yeah.
Yeah. So, and speaking of those scenarios that we'll hopefully be able to test concerning hail, you guys had some of the bigger hail stones, and every event is different. We targeted, more of the discrete supercells, which are sort of more of the lone thunderstorms. But then in Team 1, we had a mesoscale convective system, and you came over the radio. Well, I'll let you guys explain what that is. But I heard you come over the radio as we were finishing up our deployment, and you said that this was the Tail End Charlie event that you guys had been wanting to deploy on. So talk about the difference between, an MCS and some of these other storms, or what we saw, because we saw very interesting event, high concentration event with some smaller hailstones. So these storms are really they're all different.
Yeah, those, it's really been a pretty active MCS year, even when we were out in the field. But what happens to form an MCS is basically you start out with a discrete storm mode, and then the cold air that comes from these storms rushes forward and starts to push that warmer, moisture-laden air up over it, right? And so you develop these updrafts along that leading edge of the cold air, and you develop this big line segment of storms, right? But oftentimes on the southern side of that, you have an area that can still tap into the streamwise vorticity, and so you can get a supercell that kind of latches on to the southern end of this MCS. And I've heard Ian use the term Tail End Charlie all the time, so I adopted it from him. But yeah, that's generally in a nutshell what an MCS is. It's just a mass of storms moving forward, multiple updrafts, and it's being fed by its cold air.
Yeah, so this was my favorite storm for Team 1, and it was really that southern end of the line segment. We saw these just super high reflectivities, and when we went back in after the storm, there was tons of hail everywhere.
Yeah, this one was just, for me, I had the best time, and it was what turned out to be our final. It was our 10th operation period, and one to get that 10th day was sort of a team milestone. But the panel teams, Jake and Brenna, had been like knocking the socks off of us for days, and I'm like, it's the Distrometers team time to shine. And it just so happens we had put 4 probes down. These MCSs are very hard to deploy on. They're the distances you have to cover is significant. And as Jake mentioned, some of these features within them are very transient. They don't last very long. These updrafts that intensify within the line, they evolve much more rapidly. And that also means, positive from increasing hail production to waning hail production on the side. And we just happened to be in the right spot ahead of this in T1. And we noticed some small hail starting to fall on us. And we actually try to avoid being in hail almost at all costs. And so we're following what's the evolution of this tail end Charlie updraft. And that's the old storm chaser lingo, is always go for tail end Charlie because the moisture feed, the inflow is sort of uninterrupted. And that's what we did. And so we still had 5 probes left, and we decided to go really have at it and tight spacing. We made a pivot, went north a little bit to get some more distance on this cell. And I don't know why I decided that I was going to deploy disrometers this day. I usually am just buried in the laptop. Maybe because I knew Jake and Brenna were kind of out of the game away because of just how the thing evolved. I'm like, all right, I'm doing it. And Rachel's driving. And so I'm trying to call out the spacing. I don't know what Hank Pogrzelski was. So Hank's usually the one deploying in T1. And I just took it upon myself to have at it. And it was a ball because, one, you had this big looming sort of shelf cloud nearby. And this great visual environment. And you're setting up probes. And for somebody like me as the field coordinator, I don't actually do that very often. I'm usually just buried in the computer. So I'm hopping out, setting up disrometers. We finished our set of 5 probes and then came back, and we had this just amazing case of high concentration hail where you even had some drifts in some spots that were, 3, 4, 5 inches deep. And this is all this 1.5 to 1 inch, mostly 3/4 to 1 inch hail. You're talking about thousands of hailstones in just a square foot too. If you even look at one of the probe data, what does this do? And this is an area where Brenna's sort of leading some of the research that we've done. We've started to unlock that when you expose roofing materials to these events, what happens later in the aging process is far more severe than if that roof had not seen that hailstorm. So one, it was a lot of fun. It was a great 10th case. I had a ball actually doing some physical work, hopping out and doing the probe drops. But to knock out IOP 10 on a high concentration case, which is an area of our active study, was a lot of fun. And it's a great data set from an NCS that is something that's very hard to deploy on, and we do not know a lot about hail production in these mesoscale convective complexes. We know supercells are responsible for a lot of our big hail. We understand that. But we also think hail is sort of an underrepresented risk, and it's possible that there's just more hail that happens in these MCSs that we don't even know about because there's not disrometers everywhere, and hail melts really fast. For you guys who've experienced this, hailstones melt really quick. They may not be there when you get back. That's why it's so important for these kind of in situ instruments. So I loved IOP 10. It was one of my favorites now from the last few years. Just a fun, cool deployment with a great data set.
Yeah, that was really fun. We had to be very patient, but it definitely paid off with T1. So that was a cool storm. A few other things to talk about, and I feel like we could all just sit here all day talking about all of this, but we are eventually going to run out of time. We did bring the wind-driven hail probe into the field, and that's a new piece of technology. Still kind of working on it, so just tell people what that's for and how you're going to be using that in the future.
Yeah, so the concept for the wind-driven hail probe was really born out of necessity to identify the angle of impact of hail that's driven by the wind, right? And so we've done some testing here at the lab looking at hail impacts on hardy board siding, right, vinyl siding, so on and so forth. But we're testing those at a 90-degree angle of impact, which is generally unrealistic in the real world, right? Because you're going to have some downward component of that hailstone. And so to be able to identify the angle of impact of that hailstone is important for informing the testing here at the lab. So yeah, we took it out in the field. It was a mad rush to get it assembled and put together, and we didn't have time to calibrate it or anything. It was really just a first run test of the instrument, just to get some experience deploying it. How long does it take to deploy it out of the van, like to inform lead time and so on and so forth. So we ran into some bugs with the data acquisition system that we're going to be working on here in the next couple of weeks. But in general, the hardware and everything performed like you'd want it to. It's more of a software thing that we're looking into.
Yeah, we recently saw an event here locally, the Rock Hill Hail event, where we had some wind-driven hail. So this is sort of the type of thing you're going to be looking to gather more data on.
Right, yeah, and obviously roofs are the building material that suffer the most from hailstones. But I think it's somewhere around 10% of damage incurred by a hailstorm is due to siding damage, right? And like you said, the Rock Hill hailstorm, we had 80 to 90 mile an hour winds and the rear flank downdraft of this supercell that came through Rock Hill associated with 2-inch hail, 2.25-inch hail. And during the damage investigations, you could just see the siding shredded on these buildings that were in open exposure. And so really it's a problem. And obviously if the hail event is severe enough, you get water intrusion. And we heard about cases where they did have water intrusion in Rock Hill. So
yeah, that was some very severe damage down there. A couple other cool things that we got to do. We got to cross-section some giant hailstones. So I want to talk a little bit about this. We didn't collect these giant hailstones. We did meet up with kind of a colleague in the field and talk about that. That was really interesting to see. I think we had some Pizza Hut and some giant hailstones all in the hotel room that evening.
Yeah, what a novel experience. So Matt Capucci from the Capital Weather Game and Radar Omega, Matt's sort of well known out there in the meteorologist social media space. So he was out chasing on another storm not that far from us, near Levelland, Texas. Actually, I think it was near Morton. It produced these giant 4-inch plus hailstones. Well, Matt collected them. He had a cooler in his truck. And he had sent me just a DM, I think. And I knew, I told him before we left, hey, if you had a cooler, we'd take them off your hands. And sure enough, he had them in his cooler. I sent him the lat lawn of our position. And sure enough, about 5 minutes later, Matt shows up in his truck. We're handing off hailstones in gloves and bags and all that fun stuff. These were remarkably pristine stones too. I mean, just beautiful giant hailstones that, had all the pristine spikes and lumps and bumps and all that. But one of the things that both us and Penn State, Matt Cumgen, was set out to do was to prove some work that had been done in Australia. Josh Soderholm has been able to do some fantastic machine vision work looking at the ice types within hailstone cross sections through machine vision analysis. And he's done some of these sectioned hailstones in his laboratory and imaged them. We wanted to prove that this could be done efficiently and effectively in the field. This historically has been done, even NCAR and Charlie Knight has done this in years past, in a cold laboratory. So you'd have to ship the hailstones or pack them up in dry ice, take them back to the cold lab, and do this sectioning with a bandsaw in a laboratory space. Well, we're not going to take a bandsaw to the field. We're not going to sit there on the side of the road and try to do that, or even in a hotel room. It's just impractical. Well, Josh was able to do this with a hot wire cutter, which is the same little wire that you would cut like styrofoam modeling elements with if you're a crafter. So when we talked about this with Matt Cumgen, we're like, let's give it a try to see if we can do this in the field for future research projects, to be able to prove we can do these sections and image them effectively. This was a proof of concept moment. And so it was very fortuitous that Matt Capucci had these hailstones, got them to us. We took them back to the hotel. We had a great evening, ordered a bunch of pizza, and sat there and 3D scanned and sectioned these hailstones into about 1/2 inch or so slices, and you get these beautiful. I remember Brenna and I sitting there we had my TV light that's actually up here right now, like flipped over, and we put a pillowcase over the top of it to work as a diffuser and put the stone on it. And we're processing photos with our phones, and you get these just amazing images of the structure of these giant hailstones. And if you look at them, one of the unique things is most of the big outer layer of all the spikes is all wet growth. It's all clear ice. It might even be half the mass. And these are things we have never compiled a big data set on in the history of hail research. Charlie Knight has done some great work back in the day to understand these features. But in terms of like a big data set where you have thousands of these cross sections, that doesn't exist today. So we don't know that much about, the internal structure, we know what the ice growth regimes are, but the structure within it tells us so much about the path that hailstone took. And for folks who don't really follow hail science, you may have been taught in school or elementary school, the rings are from hailstones making loop-de-loops through the thunderstorm. Well, that's not what happens. They actually make this kind of wide arcing trajectory, and it's very dependent on the environmental shear, the updraft width and size, and they don't make the loop-de-loops, but they're encountering these different growth regimes as they go, and that produces that just amazing structure that you get to see. And we were able to prove you absolutely can do this in the field. We've got some ideas already. I mean, this is what happens, right? You put a bunch of scientists in a hotel room with some pizza and some hailstones, and you get a billion different ideas of how to make this better. So we already got some ideas for next year's project, as well as the potential ice chip large-scale field program, to make this a reality and start to build up a really big database of these hailstone cross-sections to be able to do some of this new machine vision work on.
Yeah, that was really cool. That's, what more can you ask for as a weather nerd to be doing that? That was my first time seeing the 3D scanner in operation. So that was really cool too. And they were huge. I mean, these stones were gigantic.
Yeah.
So we also had another opportunity, just because we mentioned it was so active out there. There are all sorts of things happening around us with other storms. And one of those things that happened while we were still in the field, we were not on this storm, but there was some, speaking of large hail, some really large hail that fell in Texas. And we also kind of jumped in to help with using some of that machine vision technology to estimate this possible new Texas record hailstone. So talk about that. That was kind of going on off to the side when we were out there towards the end of the trip.
Yeah, so another chaser is Val and Amy Castor, who actually, folks may know them from the Oklahoma City TV markets. Well, Val came across what probably will be the next Texas record hailstone from one of these. I actually don't remember the exact place he it might have been Silverton. I could be completely wrong though. But anyway, this hailstone looks like it's far bigger than the Hondo record from a couple of years ago that IBHS helped 3D scan and document. Well, Val unfortunately had no way to save the hailstone, but he took enough pictures, as well as pictures with reference objects. I think there was a Monster Energy drink can. He used one of his leather work gloves. And I tell you what, machine vision technologies come such a long way. And our own Hassam Falhalian, back at the lab, he's one of our experts, along with Faraz Hedayati, has developed some of the tools we use, is able to do a very detailed analysis of even just images. And there is an ideal set of images you can use to do a machine vision analysis, but it was enough to give us a size estimate. And it looks like this stone's probably it's going to be over the Hondo stone. The question is, what does the Weather Service accept it? Because there was no physical measurement. It was just a machine vision processing assessment, and the stone was not saved. Most records, the stone was physically measured, 3D laser scanned by us, and preserved. So that's a question that the Texas State Climate Office and John Nielsen Gammon at Texas A&M, who's also the state climatologist, is going to have to sort of wrestle with. As we have a new technology, we don't have the same stones saved like in the past records. So we'll see. We provided all the information back to the Lubbock Weather Service Forecast Office. Fortuitously, as a Texas Tech alum, I still know probably about 2/3 of the staff at the Lubbock WFO. So I'm texting with the MIC, who is a very good friend of mine and was at my wedding years ago. He was very grateful to get that information. They passed it along. So we'll see. That'll put another 2 states of record. So we would have helped document the previous Texas record with Hondo, and this one we've also done. We have the 2 Colorado records, but we're also seeing, as we learn more and more people become aware about hail, we're getting more records, right? So some of that's just awareness, right? People are going to put their pictures of these big hailstones on social media. But there's a big question as we think about the impact of our changing climate. Is hail itself, from a size perspective, are we seeing more big hail events happen? We know the frequency isn't changing much. We see about the same number of days with hailstorms, but is the severity, is the hail sizes starting to increase? Don't know. And maybe this is part of this. We don't know. That's the fun of all this science. But looks like we'll have contributed to another record that's going to go down in the book. So we should hear any day from the Texas Climate Office if that's going to become the next record.
A lot of photos that day that happened floating around next to the monster can. I think there was the stone next to a pineapple in one of the photos. So comparing it to lots of different things. But if you ever see a giant hailstone, please put it in your freezer, right?
Yes,
and
please.
save it for us.
In a bag.
In a bag.
In a bag. Yeah, this trip is could be partially sponsored by Ziploc as well as McDonald's.
That's a very good one. So unfortunately, maybe it's unfortunately, and T1 has maybe it's a team bonding thing. It's always a fish fillet sandwich from McDonald's, and McDonald's happens to be the only thing open these days. But yeah, for those out there, if you ever think you have a record hailstone, we have a guide on our website of the existing state records and need to do some updates now. Bag up this hailstone in a Ziploc freezer bag. Suck all the air out of it as best you can. Handle it with gloves, if you have rubber gloves preferably. Put it in your freezer. Stone will last quite a while if you can bag it up and keep it pristine as best you can. We had some folks who probably missed out on an Arkansas record because they were tossing it in the living room. Don't do that. Please don't do that as a scientist. But you can contribute to some great science if you have think you have a hail record. So do that. Contact your favorite broadcast meteorologist or your local office of the National Weather Service. Chances are they'll find us here at IBHS, or you can come straight to us at our Twitter accounts or social media handles, or info@ibhs.org. Shoot us an email if you think you have a record, and we'll take a look. And who knows? We've had 2 states shatter their previous record pretty fast, and I think there's probably more coming.
Yeah, definitely. So before we run out of time, I want to talk about just a couple other things. We did have a couple of partnerships this year. We had Kelly and Matt from Penn State, and then we had Joe and Becky join us from Veris. So talk about those partnerships, how they're helping us, how we're helping them, as far as what they're doing in the field out there.
So we had, like we said, we had both Becky and Joe from Verisk, and it's always nice to get, because Verisk is one of our members, and it's always nice to get someone from our member company to come out and join us and actually see what we're doing in the field and see us collecting the data and actually have them be a part of it. And we've had 2, Mark Bove last year, and then, like we said, Verisk folks this year, and they have both loved being out there and being able to deploy. And we talk about it all the time in front of them at member events and meetings, but it's really nice to get them out there and actually collecting some of that data themselves.
Yeah, and as far as Matt Cumgen and Kelly Lombardo coming out with us, I think I said at the beginning, I first got exposed to IBHS because of an opportunity to come to the field with Matt Cumgen. And he really benefits from the data that we collect with our astronomers, verifying things like hail swaths. So comparing our observations with radar-derived hail swath products and using that in his modeling that he does. And then Kelly Lombardo just recently started joining us last year and launching soundings, so weather balloons and wind sondes to get vertical profiles of the storm environment and so on and so forth. And so it's really a symbiotic relationship, I guess you could call it, between us, where like we'll use some of their sounding data, they use our astronomer data. So yeah, it's always a good time to have them join us in the field.
And Kelly's really good at getting the balloons right into the
Oh, yeah.
Yeah, we got to give Kelly a big shout out. That's the equivalent, the meteorological equivalent of a hole-in-one. An ace in golf. And Kelly, I think, was like at one point 3 days in a row, windsonde straight into a couple of supercell updrafts, which is pretty amazing. But as Jake mentioned, having that kind of sounding data is very important to understand what the environment around that storm is. And we do know from some of our past student intern work that environment does influence the type of hail, the material properties in sort of a mean sense of the hail that can come from that thunderstorm. And why that is, we think it has to do with the trajectories the hailstones take through a thunderstorm at that given time. So that's why this information is really helping drive this resurgence or renaissance in hail science. I think everybody stood up and noticed now that, we hit 10 billion back in 2008 from a loss perspective. But when you get to 20, 30, 40, $50 billion, that's a whole new ballgame from a loss perspective. And it's a peril that we cannot put our head in the sand anymore. So we need science, we need applied research, we need engineering, and we need it all together to start knocking down, at least get a handle on this loss trend. And maybe we can at least flatten out the trend right now. But the bullseye effect in terms of our growing communities are just working against us. So it's a race these days.
Yeah, and speaking of, there is another opportunity to bring all those things together. I want to look ahead to next year and talk a little bit about Ice Chip. And this is going to be one of the biggest hail research projects, I think you told me, Ian, since the 70s. Talk about that.
Yeah, so believe it or not out there, the last major multi-agency funded National Science Foundation or NOAA or anybody like that hail research project was the National Hail Research Experiment. It ended in 1978. There's been some smaller projects since that sort of touched hail. There's been a couple of ad hoc projects, and then IBHS's project came along as well as the Northern Hail Project, but there has not been a major field campaign to study hailstorms in a very long time. This is very different from hurricanes, which almost have a perpetually running field program through the NOAA Hurricane Hunter Hurricane Forecast Improvement Program. We've seen multiple tornado research projects going back to the original Vortex 1, then Vortex 2. You've got Taurus, and then the Lift projects going on right now, and there's a handful of others. But hail has had none of that, unfortunately. So our smaller projects, like what we've done at IBHS, what some others have done in the past, have had to fill in the gaps. But it looks very promising that will change going into next year with what's called the Ice Chip Project. That's an acronym for In Situ Collection of Hail in the Great Plains. Everybody's got an acronym, and I can't even regurgitate my own project. And I've said on the steering committee, we had Dr. Becky Adams-Seeland from Verisk, who's one of the principal investigators on there. Matt Cumgens in there as well. Victor Gincini, John Allen, and Andy Heimsfeld from NCAR. Some of the investigators on that project. And we got the fun word. We had to cut the budget, right? Like every government funded anything. But if it does happen, our field program will be a part of the Ice Chip Project, which is a huge milestone for just IBHS in general. We have never participated in one of these multi-agency field campaigns. We have had very big collaborative laboratory work, such as our wind-driven flame spread structure separation experiments that are ongoing right now through CAL FIRE, NIST, and even some of our fuel breaks work with the U.S. Forest Service, but never a field campaign like this. So big milestone for us, but it would enable us to study hailstorms in more detail than we've ever had, using mobile radars to do full two-dimensional wind field retrievals, lots of balloon soundings, our distrometers, a lot of ground teams collecting hail and doing the cross-sections like we were talking about, trying to prove that we can do that. So I do think if this happens, in a single year, we have the ability to learn more about the hailstorm environments and hailstorms themselves than probably we've been able to even do over the last decade, if it is a success. So our fingers are crossed. The steering committee's done some great work and has made some very, very hard decisions in terms of cutting budgets and how that affects all the hypotheses in there. But right now, it looks like this is going to be the real deal. So stay tuned for 2025 and the Ice Chip Project. If not, then we'll be back out doing our thing with our panel deployments. Probably a very similar experiment to what we did here in 2024. But we are hopeful that we will see the first major hail field experiment, multi-agency funded one, it's like 50 years. I'm trying to do the math in my head. Think about the technology, you guys out there, that has changed since 1978. Even I wasn't born. I was born in 1979. We didn't have mobile radars. We didn't have the ability to do soundings like we do today. We didn't have mobile mesonettes. Didn't have machine vision. Absolutely couldn't do that. So we can do a heck of a lot more. And looking back at the project that really gave us a lot of our foundational hail science back in the 70s. So now's the time, and I'm hopeful this does become a reality.
Yeah, definitely something to look forward to on the horizon. Well, we could keep talking. We could review all the restaurants we ate at and the hotels, but we got to wrap things up. So just kind of give your final thoughts on this year. You know, what do you guys think the data is going to look like, and what are you, I guess, most proud of this year, and just kind of final thoughts on this year's deployment.
I just started going through some of the distrometer data, probably like 2 cases so far. So I'm really excited to get that going. And I'm also really proud of how well both of our teams did with the panel deployments this year and really getting most, if not all of our panels into hail and severe hail and actually retiring a lot of those. So I'm really interested in seeing the image analysis data from that.
Yeah, I mean, we nailed it this year. We did. I mean, we blew the record out of the water, right? 10 IOP days instead of 8 IOP days. And we also, some surprising preliminary findings, I would call them, looking at the impact rated shingles that got even, severe hail, close to significant hail, which is close to 2-inch hail, but no visible damage that we could see on those panels. And so kind of the general thought is these brand new impact rated products perform relatively well against hail. But the question is, how do they stand up to hail after aging for a few years? So going forward, we're going to be looking at that as well. But yeah, just overall, this year was a huge success, I think.
Yeah, 10 operation days a record. I'm most proud of the team for it's a grind. It's absolutely a grind, and you have to do it. We all get tired of each other at some point, but you just do it. And I got to also give a shout out, Lucas Faulkner, who's not on our podcast episode, but Lucas is with Brenna and T2 and handles most of our instrumentation prep. Lucas had done a set of redesigns on some of our older distrometers, and we're finishing off the whole fleet of 24. But talk about make our lives better. I think we had to make only 2 or 3 real repairs to instruments, which is great. Like anybody knows, you're bouncing around in a vehicle, you're putting these things out day after day. Stuff breaks, right? It's electronics. Like you can't just throw your phone up against a wall 7 days in a row or let your phone get hailed on or something and expect it to work, right? So we had all our instruments that are designed to take hail, but they're in that environment. And we had so few issues. We had some data quality issues that we really wanted to solve, some ruggedness of the instruments that I think we did. And to me, that's wonderful. You're collecting high quality data. Your instruments are doing their job day after day with little problems. We had all the equipment nice and stowed in the vans, and everybody just put their head down, did the work. That's the best part of it. You have this experimental plan. It's one of the few times we get to focus on just one thing, and you go do the work. And the weather cooperated. The roads generally cooperated. And it turned out to be a really good year for data collection and hail science.
Yeah. All right. Well, it was a great trip, very successful, lots of fun as well. So thanks for letting me join you guys this year. And thanks for talking about the research. Lots of cool information. Like I said, we could just keep going on and on about all of this, but we are out of time. So Ian, Jake, Brenna, thank you for joining me on the podcast today. And be sure to tune in next month for a new episode of Disaster Discussions. We'll see you then. Thanks for listening to the Disaster Discussions podcast, an IBHS production. Subscribe to our podcast on your favorite podcast app or watch the podcast on our website at ibhs.org/disaster discussions podcast and on the Insurance Institute for Business and Home Safety's YouTube channel. Connect with us on our social media pages. And for more great content from IBHS, including ongoing research efforts happening at our facility and more, visit ibhs.org.